Okay, now suppose you have this question. Using the same skill and ASIS, draw the graph of y equals to 1 plus x, and use your graph to solve the equation x squared minus 3x minus 4 equal to 0. So first of all, in our other videos we've discussed how to use your graph to find or to solve an equation, but this question is a little bit different. They want you to draw the graph of y equals to 1 plus x, and that is a linear graph. The graph is going to be a combination of both the linear graph and the quadratic graph. First, when we started this video on graphs, we drew the curve of y equals to x squared minus 2x minus 3. But now the question wants us to draw the graph of y equals to 1 plus x. The first thing you need to do when you have a question like this is to understand first that, yes, like we said, it's a linear graph, and that you're going to draw a table. You're going to create a table of values for this linear graph. Now, like you're seeing, we've already drawn, made up the table for y equals to 1 plus x. And if you want to know how to make a table of values, you can check out our other videos. We've already done that. Now, you can just pick three values there for your table of values. You could pick just minus 2, 0, and 3, or you could pick minus 1, 1, and 3. You can pick any three values there that are not close to form your table of values for this linear graph. So when you're writing your exam, to make it faster, you can do that, but we've already drawn the table for all the ranges here from minus 2 to 5, so we're just going to use that. So we've gotten the value for y to be minus 1, 0, 1, 2, 3, 4, 5, 6. So what we're just gonna do is we're gonna plot the graph from this table. So now this is the original question that we used to get this particular graph, but let's plot the linear graph on it now. Y equals to 1 plus x. So where we have minus 2, we're gonna put minus 1. So where we have minus 2, we put minus 1. So I'm just going to take three values so that you see how we do it with three values. So I'm going to take minus 2, I'm going to take 1, I'm going to take 4, or maybe minus 2, 1, and 3. Okay, let's take it that way. Minus 2, 1, and 3. So where we have minus 2, we have minus 1. Then when we have 1, we put 2 for y, and when we have 3, we get 4. So let's do that. So we'll mark it out. So for minus 2 and x, we have minus 1, so we'll mark it out here. Okay, now for 1 we have 2, so we'll mark it out here. Now no matter any one you choose, it's just gonna follow up straight ahead. Now for 3 we have 4, so we just mark it out here. Right, okay, so now it's time for us to draw our straight line. Now let's do that. So remember, these 1, 2, 3 are the three lines. We're just going to draw it straight so that we get the lines there. Okay, so we're going to draw it straight now. Okay, so that is it. So we've drawn the line. So this is the graph of y equals to 1 plus x. The graph of y equals to 1 plus x. Let me write it out. So this is the graph of y equals to 1 plus x. So write it out. You write y equal to 1 plus x. Now this other one here is actually the graph of y equal to x squared minus 2x minus 3. So that is for this one here. Okay, so now that we know this, how can we find the roots or solve the equation? Remember, let's say it's solve the equation x squared minus 3x minus 4 equal to 0. Now where did this equation even come from? Now if you look at it, this equation actually came from the combination of the value for the linear graph and the original quadratic graph that we had, which is x squared minus 2x minus 3. Okay, so now if you combine those two, so we have y equal to 1 plus x, and we had before the quadratic graph y equals to x squared minus 2x minus 3. Putting y, the value for y here, we have 1 plus x equal to x squared minus 2x minus 3. Now you may want to solve this when you're doing your calculation in your examination, so that you just bring out how this equation came about. So now this will give us we're gonna have x squared minus 2x minus 1 minus x, minus 3 minus 1. Now 0 is going to be here, so it is the same thing as x squared minus 3x minus 4. Now this is the same thing as this we have here. So that's exactly how they got that equation. So for us to find the roots of any equation, we're going to look at how the x-axis cuts, how the curve cuts the x-axis. Sorry about that. How the curve cuts the x-axis. But for this one, because of the combination of the linear graph and the quadratic, we're going to look at where the curve cuts the linear graph. So the intersection of both the linear graph and the quadratic graph and the curve, and we're going to trace it to the value of x to get the equation, the roots of that equation. So that's exactly what we're going to do. So the points where the curve and the linear graph intercept or cut each other, these 2 points, we're going to trace it to x and then get the roots for the equation. So that's exactly what we're going to do. So if you look at it, the first one cuts at this point, so we're going to call that minus 1 for x, and this other one cuts at this point. So if you roll it down, you see that it actually cuts very close to 4. Yeah. So actually you can write that the roots of the equation is minus 1 and 4. So you can say the roots of x squared minus 3x minus 4 from the graph, like we said, where the linear graph and the curve intercept, so the intersection, you mark it out, and then you mark it out here for the x-axis only, then you get minus 1 or 4. So that's exactly what you're gonna do when you're looking for answering a question like this. Like, question like this is gonna come out sometimes, most times, so you just have to do it this way. The first thing you need to do is for you to bring out the table of values for the linear graph, then you plot it down on your graph paper. Then for you to solve the equation, you notice that the equation and the new equation is gotten from the combination of the linear graph and the old equation for the quadratic graph here, and you can find the roots by looking at the intersection between the linear graph, the linear line, that is the linear equation, and the curve, and then trace it down to x for you to find the roots of the equation. So that is it.